Everyone, Anirudh here. I am a student of IIT Kanpur, a third year undergraduate, not a second year, third year undergraduate student of the Department of Computer Science and Engineering enrolled in this BTech course. I am a resident of Chennai and I secured the All India rank 237 in JEE Advanced 2021. Right. This is part 2 of trigonometric functions, which is chapter 3 of class 11, in which I'll be dealing with exercise 3.3. In the last part, we left out at the brief before exercise 3.3, where I've given you the pertinent information about the different functions and the different formulae that you'll be encountering in trigonometric functions, right? So we'll be dealing with that in this exercise. This is just a primer to get you used to what those different formulae are and how you're going to use it in different equations, right? So the first question, prove that sine squared pi by 6 plus cos squared pi by 3 minus tan squared pi by 4 is minus 1 by 2. Pretty easy. First, notice that each of these angles are your standard angles, right? Pi by 6, if you remember your radian conversion formula, pi by 6 is basically 30 degrees, right? That means that pi by 3 is going to be 60 degrees. And pi by 4, of course, is 45 degrees, right? You know the sine, cos, and tan for each of these three angles, right? Because your standard tables start from 0, 30, 45, 60, and 90, right? So the first question is going to be very fairly simple, right? It's going to be direct substitution of your values. So it's sine squared pi by 6 plus cos squared pi by 3 minus tan squared pi by 4 being equal to 1 by 3, minus 1 by 2, right? So I'll take the LHS first. Take the LHS, right? Let LHS be equal to L. This expression, this whole thing, let it be equal to L. This thing, let it be equal to R. Right, just for simplicity's sake, for me to write an equation properly, right? So your L is going to be equal to, this is sine squared pi by 6 plus cos squared pi by 3 minus tan squared pi by 4, right? It's a plain writing this again, but I have to write a whole equation, then I have to do this. Right? And you all know the value of sine pi by 6, that is half. Right, since it's sine squared, you square half, right? Plus again, cos pi by 3 is cos 60, that is again half, right? Minus tan pi by 4 is 1. 1 squared or 1 power anything is again 1. So you do a minus 1, right? Therefore, you get that L is equal to 1 by 4 plus 1 by 4 minus 1, which is basically, this is half. Half minus 1 is minus half. That is minus 1 by 2, right? Which is equal to R, because R is basically what? R is basically one value, that's minus 1 by 2. You can see that L is also equal to minus 1 by 2. So you have the fact that LHS is equal to the RHS, right? Therefore, you have proved the first one. That's it, right? Fairly simple, but that is because the angles that are given are standard angles. If they're not standard angles, then you'll have to use some kind of a combination or a permutation trick to get to reduce these angles so that they cancel out, or they they come back to a standard form, right? For example, you can see that in the second question. I mean, not really, because 7 by 6 is again almost a standard angle, but yeah, right? Question number 2. Question number 2 states 2 sine squared pi by 6 plus cosecant squared of 7 pi by 6 into cos squared of pi by 3 is going to be equal to 3 by 2. Right? That's what they're given. Again, same as before, let the left hand side of the equation be equal to L, let the right hand side be equal to R. That's going to enable me to write equations better. Yeah. So I'm going to write L is equal to, I'll just say this again because it's going to give a better, better continuity, better viewing experience. So this is what? This is cosecant squared 7 pi by 6 into cos squared pi by 3. Right? Again, sorry for my board work, but I don't have a tabs ready for the mouse. This well, right? And again, substituting, these are standard angles, substituting the values of these standard angles. Side pi by 6, as you all know, as I stated earlier in the first question, that's half. I'm going to, reduce a step, write that half squared is 1 by 4, and 2 into 1 by 4 is basically 1 by 2. Right? This is half plus, this is cosecant squared of 7 pi by 6, right? Remember that 7 pi by 6 is basically pi plus pi by 6, right? And I'll just write it over here because I don't want to congested the main space, right? Remember that sine of pi plus theta is going to be equal to minus sine theta, right? This is, if I'm not wrong, it's given over here. I don't know which number. Yeah, over here, number 9. You can see that you have sine of pi minus x being sine x, you have sine of pi plus x being minus sine x, right? Instead of x, I've used theta. That's the only difference. All right. So given that sine of pi plus theta is minus sine theta, you should all know that cosecant is basically 1 by sine. And since this pi plus theta is not going to be 0, right? 1 by cosecant of pi plus 1 by sine of pi plus theta is also going to be minus 1 by sine theta. So basically, cosecant of pi plus theta is going to be cosecant minus cosecant theta, right? That's why I've used sine here, because cosecant is basically 1 by sine. Right. So since this can be represented as cosecant squared of pi plus pi by 6 times cos squared pi by 3, right? Again, this is cos squared of 60 degrees, that's 1 by 4, right? As I stated earlier in the first question. So this is basically half plus, this is cosecant squared of pi plus pi by 6, that is minus cosecant pi by 6 the whole squared into 1 by 4, right? Yeah. Now remember that cosecant pi by 6 is 2. It's not half. Sine of pi by 6 is half. Since cosecant is 1 by sine, this is 2. Right. So this is therefore half plus minus 2 the whole square divided by 4. Right. And since 4 is basically 2 squared and minus 1 squared is 1, this is going to give us 1. Right. So this is basically 1 plus half, that is 3 by 2. Right. Which is equal to R. Because on the right hand side you have 3 by 2. Right. Therefore, you have stated that LHS is equal to the RHS. Therefore, you have to the statement. All right. That being the second question. Again, fairly easy since you all have standard angles and you can basically condense this into another standard angle, pi plus theta, pi minus theta, whatever. Right. Question number 3. Sorry for that. Cot square pi by 6 plus cosecant. Okay, this is basic. All right. Cosecant of 5 pi by 6 plus 3 tan square pi by 6 is going to be equal to 6. Right? First of all, note that pi by 6, this is 5 pi by 6, this is again pi by 6. All our standard angles, you can basically, substitute the values of these standard angles inside the equation, right? You don't really need to think a lot on it, right? So first of all, this is cot pi by 6, that's cot 30 degrees, right? And cot 30 degrees is root 3, right? So this is basically root 3 the whole square. I can write L is equal to this expression. I'm not writing it again. Okay, I'll write it again. Fine. Because I lose continuity. Then this is cosecant 5 pi by 6 plus this is 3 tan squared pi by 6, right? All right. So this is basically square root 3 the whole square, right? Cosecant 5 pi by 6 is basically cosecant of pi minus pi by 6, right? And for the last question I showed you earlier, sine of pi plus theta is going to be minus sine theta. The same way, sine of pi minus theta is going to be equal to plus sine theta. Why? Because pi minus theta is going to lie in the second quadrant, right? Pi is basically 180. This is sine of 180 degrees minus theta in degrees, right? So this lies in the second quadrant, and the second quadrant sine is positive. Cool. So you have this to be cosecant of pi minus pi by 6, which is equal to cosecant pi by 6, which is equal to 2. Right. Again, 3 times square pi by 6. That is going to be 3 times of 1 by root 3 the whole square. Right, because tan and cot is basically an inverse relation. Tan and cot is tan theta and cot theta is 1. So you have 3 tan square pi by 6 being 3 into tan 1 by root 3 the whole square, right? Which is basically 3 times 3, that is going to give you 1, right? So this is 3, right? Therefore, the LHS L is going to be 3 plus 2 plus 1, which is equal to 6, which is equal to R. Right, because on the right hand side you have 6. Therefore, you state that LHS is equal to RHS. Thus, you have statement. Right. That concludes the third question. Question number 4. 2 sin square 3 pi by 4 plus 2 cos square pi by 4 plus 2 secant square pi by 3 is 10. Right. Again, very simple because all you have are standard angles. 3 pi by 4 is basically 135 degrees, right? I don't need to worry about that because sine of anything in second quadrant. I mean, if you see a square, you can basically blindly put it to be positive because all square numbers are positive. You can't have a negative square number unless it's imaginary, right? Unless it's complex, not imaginary. Whatever. So this is 2 cos squared pi by 4 plus 2 secant squared pi by 3 is going to be equal to 10. Right? Let me just do this properly. Yeah. All right. So you have L to be 2 sine squared of 3 pi by 4. Right? Remember that sine of 135 degrees is 1 by root 2. That's basically pi minus pi by 4, and sine of pi minus pi by 4 is 1 sine pi by 4, which is 1 by root 2. Right? Plus this is 2 cos squared of pi by 4. Again, cos of pi by 4 is 1 by root 2. Right? You should all remember these standard angle values. And this is 2 secant squared of pi by 3. Right? Again, secant of pi by 3 is the same as cosecant pi by 6. That is 2. Right? So secant squared is going to be 2 squared. That is 4. Right? So this is going to be equal to 2 times 1 by root 2 the whole square. This is going to give me a 1. Plus 2 times, again, 1 by root 2 the whole square. Again, this is going to give me a 1. Right? Because 1 by root 2 the whole square is 1 by 2. And 2 into 1 by 2 is 1. Right? Plus this is 2 times 2 the whole square. Right? Which is basically 1 plus 1 plus 8. Because this is basically 2 cubed, right? And 2 cubed is 8. This is equal to 10. Which is the right hand side expression. Right? Because this is a 10. Therefore, you can state that LHS is equal to the RHS. Therefore, you have this statement. Right. Remember to write hence proved, because if you don't write this, people won't get if you have actually proved or if you have just left it at the middle step. Right? This provides a decent ending to your statements. I mean, it's just style, but it's good habit. Right. That's question number 4 are taken care of. You're going to question number 5. Right? This is where it gets a little bit tricky. Find the values of sine 45 degrees. First things first. So first things first. When you start, using all these different values, 75, 15, 37, 53, whatever. Right? When you start doing lots of different problems like people do for JEE mains or JEE advanced, right? You start remembering these values by heart, right? So if you really ask me, find the value of sine 75 degrees, I'll just say it's root plus 1 by 2 root. But yeah, how do you get it, right? So the first part, right, sine of 75 degrees. This you usually break it down as 30 plus 45, right? Usually when these kinds of questions are asked, try seeing if the given value, right, if the given value can be represented as a sum or a product or some kind of a difference, or a multiple of these kinds of standard angles, 30, 45, 60, right? In case you remember the values of sine 15 degrees or cos 15 degrees, then you'll also go for 15 and 75, right? Because they're complementary angles, and you all know the rules for complementary angles, right? So these kinds of, these kinds of different angles, you can try seeing if the given angle is a composition of them. If it is a composition, then you know the different formula that can be used. You know how you can break it down and how you can get the value, right? So for example, if you're asked for sine of 22.5 degrees, that is basically sine of 45 by 2, right? But I don't think you have dealt with half angle formulas, right? So that's going to be a little bit tricky, but yeah, that's just what I mean, right? 22.5 is going to be 45 by 2. If you know the half angle formula, then it's going to be easy. Quite a digress, right? So this is 30 plus 45, that's 75, right? And 30 and 45 are going to be standard angles, right? So I can write this, let this be, what can I write? Let this be A, right? A for answer, right? A is going to be equal to sine of 30 degrees plus 45 degrees, right? You all know this because degrees angles are linear additive, right? So 30 degrees plus 45 degrees is basically 75 degrees. It's not something like a vector where you have to, think of the cosines and whatever, whatnot. Right. So this is sine of 30 plus 45. Remember the sine rule, where sine of x plus y is basically sine of sine x cos y plus cos x sine y. The only pain here is writing the whole thing out. Otherwise, it's very easy. Right. And you all know the values of these standard formulae. Sine 30 degrees is half. Cos 45 degrees is 1 by root 2. Plus cos 30 degrees is root 3 by 2. And sine 45 degrees is 1 by root 2. Right? So this is basically 1 by 2 root 2 plus root 3 by 2 root 2, which is basically root 3 plus 1 divided by 2 root 2. Right? So this is the value of sine of 75 degrees. Sine of 75 degrees. Right? From this, you can also say that cos of 15 degrees is going to be equal to root 3 plus 1 divided by 2 root 2. All right. Because sine 75 is equal to cos 15. They're complementary angles. Right? Similarly, you can say that since, this is 30 plus 45, but what if you take 45 minus 30? That means that sine of 15 degrees, right, is going to be equal to cos of 75 degrees is going to be equal to root 3 minus 1 divided by 2 root 2. Right? Because the only place where you change for 15 degrees and 75 degrees is this plus. Right? Instead of there being a plus 30 degrees over here, for 15 degrees, you'll do a minus 30, which means that you will get a minus sign over here. But since this is cos minus theta is also cos theta, this is going to be a plus. Right? So this you will basically get a root 3 by 2 root 2 minus 1 by 2 root 2, which is basically root 3 minus 1 by 2 root 2. Right? This is just extra information. You can do it that way. Or if you are, much more confident, right, you can use the sine of a plus b formula or cos of a plus b formula to find out what this is going to be, because sine of 75 plus 15 is going to be sine 90. Right? With that also, using that also, you can get the values of sine 15 plus 75. But yeah. And then you have the second subpart, that is tan 50 degrees. Right? First thing, since you know the value of sine 15 and cos 15 over here, from this you can directly say that tan 15 is going to be sine of 15 degrees, right, divided by cos of 15 degrees. Since I've written both these values over here, I can basically say that this is going to be root 3 minus 1 divided by root 3 plus 1. Right? But that's not what they're expecting, right? You need to use the standard formula. You have to condense it and then blah, blah, blah. Right? So for 15 degrees, again, what you do is you take this to be 45 degrees minus 30 degrees. Right? Standard angles, both of them. And you have a subtraction over here to get 15 degrees. Right? And so you can do if this is going to be A again, right? This is A is equal to sine 75 is equal to this perfect. Yeah. So you have A to be tan of 45 degrees minus 30 degrees, right? Again, tan of x minus y, you're going to use a formula that is going to be tan x, tan of 45 degrees minus tan y, that is tan 30 degrees, divided by 1 plus tan x into tan y. Right? Which is basically, this is 1 minus 1 by root 3 divided by 1 plus 1 by root 3 into 1, right? Because tan 45 is 1. Yeah. So if I, rationalize this, I just multiply root 3 on both the numerator and the denominator. I'll basically get this to be root 3 minus 1 divided by root 3 plus 1, which is what I've written earlier. But this is by the tan formula, while this is by, taking the values of sin inverse. Yeah. So this is what you get. This is the value of tan of 15 degrees, right? And since you know that this is going to be equal to cos 75 degrees, right? That means that tan of 75 is basically 1 by cos 75, right? So tan 75 degrees is going to be the inverse of this. So it's basically going to be root 3 plus 1 divided by root 3 minus 1. Right? So you know these 6 trigonometric formulae for sine of 15 for 15 degrees and 75 degrees. And if you're going to be asked in radians, 15 is basically pi by 12. All right. And 75 is going to be 5 pi by 12. Right? These are the two angles that you have the values for. Right? This is going to be 15 degrees, and this is going to be 75 degrees. Right? That takes care of question 5. From question number 6 onwards, it's going to be a little bit trickier because you're going to be working with variables x and y and not exactly standard angles themselves, right? And so you're going to be using some kind of condensation formula, etc., so on and so forth. Question number 6 states that cos of pi by 4 minus x into cos of pi by 4 minus y minus sin pi by 4 minus x sin pi by 4 minus y is going to be equal to sin of x plus 1. All right. So first things first, note what kind of, what this left-hand side is reminiscent of, right? Note that. I'll come to that in a minute. I'll just cover the question and then I'll say how you are going to solve it, right? This is cos of pi by 4 minus x, cos of pi by 4 minus y, minus sine of pi by 4 minus x into sine of pi by 4 minus y. It's going to be equal to sine of x plus y. Right? Same rules of L and R as before. Right? I will first take L because I like working with the left hand side. Right. So for L, first, I'll make the substitution that pi by 4 minus x is going to be my angle capital A. Similarly, pi by 4 minus y is going to be my angle capital B. Therefore, L is equal to cos A cos B minus sin A sin B. Right? Note that cos of x plus y is cos x cos y minus sin x sin y. Right? Since I've basically substituted A and B for x and y, right? So this is basically equal to cos of A plus B. right? Back substituting A and B, right? Therefore, L is going to be equal to cos of pi by 4 minus x plus pi by 4 minus y, which is going to be equal to cos of pi by 4 plus pi by 4 is pi by 2 minus of x plus y, right? And cos of pi by 2 minus theta is going to be equal to sine theta, right? You all know this. Cos of 90 minus theta is sine theta, which is the right hand side expression. Therefore, LHS is equal to RHS. Thus, hey, that is question number 6. Number 7. Tan pi by 4 plus x by tan pi by 4 minus x is going to be equal to 1 plus tan x divided by 1 minus tan x, the whole square. Right? Just give me a second, the mouse is not working. Yeah. Right. Tan of pi by 4 plus x divided by tan of pi by 4 minus x is equal to 1 plus tan x by 1 minus tan x, the whole square. All right. But here, you know, the simplest way to do this is by expanding these formulae. No other go. Right. So what you do is take L, right? This is basically tan of pi by 4 plus x divided by tan of pi by 4 minus x, right? You may know this as an addendum to, you know, the different rules. If they haven't given tan of pi by 4 plus x as a rule, right? You may note that tan of pi by 4 plus x is going to be equal to 1 minus tan x, 1 plus tan x, I'm sorry, 1 plus tan x divided by 1 minus tan x, right? Substitute pi by 4 in place of tan, you know, if you're going to be doing tan of pi by 4 plus y, right? Instead of tan x plus tan y, instead of tan x in the equation of tan of x plus y, you substitute tan of pi by 4, that is 1, right? So this is basically 1 plus tan y by 1 minus tan y. But since I've used pi by 4 plus x, it's 1 plus tan x by 1 minus tan x. Similarly, if there was a minus over here, then this will be a minus, this will be a plus, right? Basic interchange of signs, right? It also stems from the fact that pi by 4 is going to be, you know, the midpoint of 0 and pi by 2. So pi by 4 plus x and pi by 4 minus x are going to be complementary angles, right? And so it's going to be an interchange of numerator and denominator. Okay. So having stated that, I'll basically do this to be 1 plus tan x divided by 1 minus tan x, right? All divided by this is tan of pi by 4 minus x. As I stated earlier, this is basically an inverse of tan of pi by 4 minus x, right? This is going to be 1 minus tan x divided by divided by 1 plus tan x, right? Yeah. So with this is going to go here, this is going to go over there, right? So I'll basically be getting this to be 1 plus tan x the whole square divided by 1 minus tan x the whole square, which is basically the right hand side, right? Right hand side is 1 plus tan x by 1 minus tan x the whole square, right? Which is basically right hand side. So I have proved that LHS is equal to RHS. Therefore, I've proved the statement. This is question number 7. Question number 8. Cos of pi plus x times cos of minus x divided by sine of pi minus x into cos of pi by 2 plus x is going to be equal to cos squared x. All right. So first things first, cos of pi plus x. Note that this is going to be in the third quadrant, right? Cos of pi plus theta is going to be cos minus cos theta. All right. Cos of minus x is going to be cos x, right? Because you all know that cos is an even function, right? Therefore, cos of minus x is going to be cos x. Sin pi minus x, on the other hand, this is going to be in the second quadrant, and in the second quadrant sin is positive. So this is just going to be sin x. While this, on the other hand, this is cos of pi by 2 plus x. Since cos is negative in the second quadrant, this will be minus of sin x, right? So L is going to be equal to cos of pi plus x into cos of minus x divided by, just restating the question over here, pi minus x cos of pi by 2 plus x. Right, this is equal to this is minus of cos x into cos x divided by, this is going to be sin x, right, into, this is going to be minus sin x. Minus and minus cancel out. This is going to be equal to cos squared x divided by sin squared x. This is equal to cot squared x, which is the right hand side. Therefore, I've proved that the LHS is equal to the RHS. Therefore, I've proved the statement. That's question number 8. Right. Question number 9. Cos of 3 pi by 2 plus x into cos of 2 pi plus x into this whole thing is equal to 1. Right. So for question number 9, what I'll do is I'll directly jump in with the left hand side of the equation. That is going to be cos of 3 pi by 2 plus x into cos of 2 pi plus x. Remember what I told you earlier, if you have some kind of 2 and pi over here, you can basically ignore it because that's a full revolution, right? And that affects nothing, exactly nothing. So this is going to be cos of 2 pi plus x, 1 into cot of 3 pi by 2 minus x plus cot of 2 pi plus x, right? So this is going to be cot of 3 pi by 2 plus x, right? This is minus x. 3 pi by 2 minus x plus cot of 2 pi plus x. Again, 2 pi, full revolution. So I can basically ignore it, right? This I'll rewrite as, since this is cos of 3 pi by 2 plus x, this is going to be positive in the fourth quadrant. So this is basically going to be sin x, right? Into, this is going to be cos x whole times, this is cot of 3 pi by 2 minus x. This is going to be the third quadrant, right? Since it's a multiple of pi by 2, you are going to, change the angle, change the ratio to tan, right? And since it's in the third quadrant, it's going to be positive. So this will be tan x plus, this is going to be cot x, right? Therefore, you'll be left with sin x times cos x. That is, I'll basically write it. This is sin x and cos x into tan x is basically sin by cos, right? So I'll write this as sin x divided by cos x. Cos x and cos x cancel out. You're left with sin squared x. Plus, this is going to be sin x times cos x. Since cot is cos by sin, you're going to be having cos x divided by sin x. Sin and sin cancel out. Right? So L is basically equal to sin squared x plus cos squared x. That is equal to 1. Therefore, right, since the right hand side is also equal to 1, this is equal to R. Therefore, LHS is equal to RHS. Therefore, true. Right. Question number 9. Going to question number 10. Sin of n plus 1x into sin of n plus 2x plus cos of n plus 1x into cos of n plus 2x is equal to cos x. All right. Again, think of what this equation is reminiscent of until I write the left hand side. Right. Again, I'm going to write only the left hand side. I'm not going to deal with the right hand side. Right. Let the right hand side be r itself. You know that r is cos x, single expression. So I'm not really bothered with it. Right. L is equal to, I just switch the orders a bit. Right. This is cos of n plus 1 times x into cos of n plus 2 times x. Right. We will also again remember that if you are going to not specify a multiplication, or if you're going to have something else apart from a single cosine or a sine or a tan expression, remember to put brackets around the x also. That removes ambiguities. Sometimes what happens is you will have a big run-on expression like x cos x sin x into x, something like that. Right, and it'll be difficult for you to figure out if the x is inside the sign bracket or if it's outside. So it's generally a good practice to cover the x's with the brackets also. Since I have seen this over here, it's not it's without the brackets, right? And some people may follow it. I'm just warning you against that. It leads to ambiguities. That's it. Right. This plus sine of n plus 1 times x sine of n plus 2 times x, n plus 2 times x, right? Let me deal with two substitutions, right? Let n plus 1 times x be equal to a. Let a plus x, that is, wait, that's a cute way, but let n plus 2 times x be equal to b, right? Therefore, L is going to be equal to cos A, cos B, plus this is sin A, sin B. We will remember that cos x, cos y plus sin x, sin y is basically cos of x minus y, right? Or cos of y minus x, whatever. Both are the same, because cos of minus x is cos x. So you have this to be cos of A minus B. Right? Back substituting A and B, this is basically cos of n plus 1 times x minus n plus 2 times x, right? Which is basically cos of minus x, which is equal to cos x, which is r. Therefore, I have LHS is equal to the RHS. Therefore, I have proved the statement. Cool. Question number 11. This is going to be pretty simple, right? Since again, you the only things you have are standard angles. You don't really deal with, you don't really have to think on it a lot, right? So this is fairly simple. Again, we'll deal with the left hand side only because the right hand side is a very simple expression, right? L is equal to cos of 3 pi by 4 plus x minus cos of 3 pi by 4 minus x. All right. To do this, what I'm going to do is basically expand each of the cos terms, right? Since it's 3 pi by 4 plus x, then 3 pi by 4 minus x, you have a decent chance that some of these 3 pi by 4 terms will cancel out. Or you can, convert them to their numerical forms and then work just with cos x and sin x. That's also a way. So just expanding this, right? Cos of x plus y is cos of x cos y minus sin x sin y, right? Sin of 3 pi by 4 into sin x. The dot is into. For all those of you who haven't heard of the the dot operator, the dot is into. Minus, this is going to be cos of x minus y, that is going to be cos x cos y. plus sin x sin y, right? So this is going to be cos of 3 pi by 4 into cos x plus, I'll put a bracket over here, right? Because this is an external sign. These are internal signs, right? This is going to be plus, wait, what am I even right? This is going to be cos x cos y plus sin x sin y, right? Sine of 3 pi by 4 times sin x. Cool. So this is going to be equal to, this is 1 by root 2. All right, wait. Cos of 3 pi by 4 is basically cos of 135 degrees. That is minus sin 45. That is minus 1 by root 2. Sin 3 pi by 4 is 1 by root 2 because sin is positive in both quadrants, in the first and the second quadrant, right? Just remember that. I'll make the numerical substitutions. So this is basically cos minus cos x by root 2. This and this is minus sin x by root 2, right? This is minus of, this is minus cos x by root 2. And this is again, this is going to be plus sin x by root 2. Now removing the brackets, you are basically left with minus cos x. Minus of minus is plus, right? So this is going to be minus cos x plus cos x divided by root 2 plus, this is going to be minus sin x because minus and plus is minus, right? Minus sin x divided by root 2. This is going to give you a 0, right? And this is going to be minus 2 sin x by root 2. Since 2 by root 2 is basically root 2, I will basically write this as minus root 2 times sin x, which is the RHS, right? Therefore, I can say that LHS is equal to the RHS. Therefore, I have put the statement. That's question number 11. Right. Question number 12 onwards is a little bit more trickier, right? In the sense that you are going to be dealing with multiple angles. Cool. And by multiple angles, what I mean is multiples of angles. That is 6x, 4x, 2x, 3x, 5x, whatever. Right? Remember the two major formulae for the multiple angles. That is sine of 2x, sine of 3x, cos of 2x, cos of 3x, tan of 2x, tan of 3x. Right? Remember those formulae. Very important formulae they are. You'll be using them in many places, right? Where these kinds of condensations are important. Cool. So let me deal with question number 12. Just a minute. Good. So let me deal with the 12th question. Sine squared 6x minus sine squared 4x is equal to sine of 2x into sine of 10x. Right? Notice that this is in the form of a square minus b square, which is equal to a plus b times a minus b. Right? All right. So the left hand side I can basically write as sine square 6x, right, minus it is sine square 4x brackets, which is equal to sine of 6x plus sine of 4x whole into, this is sine of 6x minus sine of 4x, right, brackets, yeah, which is equal to, Remember that sine of x, sine x plus sine y is going to be what? 2 sine of 6x plus 4x by 2 into cos of 6x minus 4x by 2. Right? Into this is going to be sine of x minus sine y, right? Which is basically 2 times sine of a minus b by 2, that is going to be 6x minus 4x divided by 2 into cos of 6x plus 4x divided by 2. Right? So you basically have this to be 2 sine of 5x into, this is going to be cos x, into 2 sine x into cos of 5x. Right? Collecting like terms, like, and by like terms I mean the terms with the same, the same angle, the same multiple of the same angle. Right? So I can basically write this as 2 sine of 5x into cos x. Right? Wait. Into, this is going to be cos x, cos of 5x into, this is going to be 2 into sine x into cos x. Right? Remember that 2 sine a cos a is going to be sine of 2a. Right? This is going to be equal to, wait, what's happening? This is equal to, this is sine of 2 into 5x into sine of 2 into x which is equal to sine of 10x into sine of 2x, which is the right hand side, right? Which is the right hand side. Therefore, I can state that LHS is equal to the RHS. Therefore, I have put the statement. That's question number 12 done. Question number 13. Cos square 2x minus cos square 6x is equal to sin 4x sin 8x. The exact same way that you do this question, you're going to do this question. All right. So here I'm going to drop off R. I don't have anything to do with the right hand side. So I'm only going to deal with the left hand side. Right. L is equal to, this is cos square 2x minus cos square 6x. Right. Which is basically, this is cos of 2x plus cos 6x into cos 2x minus cos of 6x. Right? The first part, this is going to be equal to cos a plus cos b is going to be 2 into cos of a plus b by 2 into cos of a minus b by 2. While cos of a minus b is going to be 2 sine a plus b by 2 into sine of b minus a by 2. All right. Remember the switch in the signs, right? For cos of a minus b and sine of a minus sine a minus sine b and cos a minus cos b. There's going to be a switch in the signs. Remember that. All right. Do not forget, because if you forget it, your answer is going to go wrong. With that said, right, I'll proceed with the question. Right, this is going to be 2 into cos of 2x plus 6x, that is going to be 8x divided by 2. And cos of 6x minus 2x divided by 2, that's going to be 4x by 2. Right? If it's going to be 4x or minus 4x, nobody cares, because cos minus theta is cos theta. Right? This into 2 into sine of 8x by 2. into sine of, this is going to be 4x by 2 because you're doing b minus a by 2 and not a minus b by 2. All right. So this is going to be a sine of plus 4x by 2. It's not minus 4x by 2. Remember that. So you are basically left with 2 cos 4x into cos x, right? Wait, this is cos 2x into, you have 2 sine of 4x into sine of 2x, right? Now you are going to collect the like terms, right? This is equal to the collection of 2 into cos of 4x into this is sine of 4x, right? Into the collection of 2 cos of 2x into sine of 2x, right? Which is basically sine 8x into sine of 4x, which is the right hand side. Therefore, I can say that LHS is equal to the RHS. Therefore, I have put the statement. Yeah. Going to the 14th question. Sine 2x plus 2 sine 4x plus sine 6x is equal to 4 cos square x into sine 4x, right? The sine 4x gives us a clue as to what we have to take common and what we have to do. Okay. So first things first, know that there is a 2 sine 4x over here. Remember that. With that, I think we can, proceed to the question. Right. I can do this in 2 ways, right? A, I can split this 2 sine 4x as sine 4x and sine 4x. I can do, combination of sine 2x plus sine 4x. I can do a combination of sine 4x plus sine 6x, and then I can arrive at the answer. Or I can directly do sine 2x and sine 6x. Whatever I get, with that I can take common with sine 4x, and the rest I can, try to condense to form 4 cos square x. Right? Both ways should give me the answer. But the easier way is going to be the way I suggested second. So I'm going to deal with that. Again, the right hand side is a fairly simple expression. I'm not bothering with that. Right? L is equal to, this is sine 2x plus 2 times sine 4x plus sine of 6x, right? So I can basically combine these two. This forms 2 into, this is 2 sine of, since it's a plus, is going to be 2 plus 2x plus 6x divided by 2. That is going to be 8x by 2 into cos of, this is going to be 2x minus 6x by 2. That is going to be 4x by 2. It's actually minus 4x by 2, but since cos of minus theta is cos theta, I'm not bothering with the minus. Right. So this is going to be 2 sine of 4x into cos of 2x. All right. So we basically have L to be equal to 2 sine 4x into cos 2x plus 2 sine 4x. Right? Which is basically 2 into sine 4x into cos of 2x minus 1. It is cos 2x plus 1. Right. Remember that cos 2x has many different forms, and one of those forms is basically 2 cos square x minus 1. Right. Therefore, L is equal to 2 into sine of 4x times this plus 1 and this minus 1 get cancelled out. So I'm basically left with 2 cos square x. Right. So this then becomes 4. 2 into 2 is 4 times this word 4 into cos squared x into sine of 4x, right, which is equal to r. This below. Therefore, LHS is equal to the RHS. Therefore, you have this statement. All right. That's question number 14, right? This was yes. Going on to question number 15. Cot 4x into sin 5x plus sin 3x is equal to cot x into sin 5x minus sin 3x. That's a better question, no? This kind of makes me think. Right. So first things, I'll write the question down. This is cot 4x into sine of 5x minus sin 3. This is plus. Okay. This is plus sin 3x. Right. This has to be equal to cot x times sine of 5x minus sine of 3x. Right. Same rules. Let this be L, let that be R. Right. So L is equal to, I'll basically combine this, I condense this with the sin x plus sin y formula. Right. So I'll be left with part of 4x into 2 sine, since it's a plus, is going to be a plus sine of a plus b by 2 into cos of a minus b by 2. Right. And since this is 5 plus 3, I'll basically skip a step. Instead of writing sine of 8x by 2, I'll write this as sine 4x. Right. I just draw 4 a bit clearly. This is what the hell. This is sine 4x. Right. Into, this is going to be cos of 5 minus 3x, 5x minus 3x divided by 2. That is going to be 2x by 2. That is going to be x. Right. So this is basically, if I, remove this cot, right, I'll basically resubstitute this as cos of 4x divided by sine of 4x, because that is true, right? So this is going to be cos 4x divided by sine 4x into 2 sine of 4x into cos x. Right? And this sign is going to get cancelled. This is equal to 2 cos 4x into cos x. Right? Now I can simplify this further. If I simplify this further, what I'll get is, since this is 2 cos a into cos b, I'll basically get something of the sort cos something plus cos something else. Right? There is another case for the right hand side over here, because there is cot x times sine of something minus sine of something. So I can't basically do this with cos. I have to, reduce the right hand side also. So let me take r. Right? R is equal to cot x into sine of 5x minus sine 3x. Right? This is equal to, since this is sine a minus sine b, I'll basically substitute cot x also over here. This is going to be cos x divided by sine x into 2, this cos of a plus b by 2, cos 4x into, this is going to be sine of a minus b by 2. All right, this is going to be sine of x. Sin x and sin x is cancelled. This is again equal to 2 cos of 4x multiplied by cos x. Right? You can see that the reduced form of the left hand side and the reduced form of the right hand side are equal. Therefore, you can say that LHS is equal to the RHS. Therefore, you have to the statement. All right. That finishes question number 15. Question number 16. Cos 9 minus cos 5 by sin 17 minus sin 3 is minus sin 2 by cos 10. Right. Again, looks pretty confusing, but it's easy, I assure you. Right? First things first, know the numerator. Right? For question number 16. Right? I'll deal only with the left hand side again because the right hand side is a very simple expression. Right? This, I'm sorry for that. This is going to be cos of 9x minus cos of 5x divided by sine of 17x minus sine of 3x. Right. You should know the formula we know. Cos A minus cos B is going to be 2 sine of 9 plus 5, 14 by 2, that is 7x into sine of 5 minus 9, that is going to be minus 2x. Right? It's because it's 5x minus 9x divided by 2. So it's going to be minus 2x divided by sine A minus sine B. Again, the formula is 2 into cos of 17 plus 3 by 2, that is going to be 10x, because 17 plus 3 is 20, into sine of, it's going to be 17 minus 3 divided by 2. Right? That is again going to be 7x. So this 7x and this 7x is going to get cancelled. This will get cancelled. You are basically left with minus sine of 2x, because sine of minus 2x is minus sine 2x. Sine is odd. Right? Divided by cos of 10x. Right? Which is equal to r. See, I told you, very easy. Right? Therefore, you can state that LHS is equal to RHS. Therefore, you have this statement. I have to copy paste this. If I can actually make a cutout of this, I can basically do control V again and again. I don't need to spend time writing this. But yeah, anyways, right? That's 16. Question number 17. Sin 5x plus sin 3x by cos 5x plus cos 3x is equal to tan 4x. Very simple again, right? The same principle as question number 16. I'll again take LHS only, right? Let this be sine of 5x. Let this be sine of 3x divided by, this is going to be cos of 5x plus this is going to be cos of 3x. Remember the formula, sin A plus sin B is going to be 2 sine of A plus B by 2, that is going to be 4x into cos of A minus B by 2, that is going to be x, divided by, this is going to be 2, this is cos A plus cos B, this is going to be 2 into cos of A plus B by 2, that is going to be 4x into cos of A minus B by 2, that is going to be x. X and x cancels out, 2 into cancels out, you are left with sin x by sin 4x, sine of 4x divided by cos of 4x, which is equal to tan of 4x, which is r. Right? Therefore, LHS is equal to RHS. Therefore, proved. Right? F 17 questions. Now you're left with what? Here is 25, and then there's 10 in this page. Right. So 17 is done. Going to question number 18. Right? Sin x minus sin y by cos x plus cos y is tan of x minus y by 2. Right? What you do over here is basically the same as what you do over here, except for the fact that here you are dealing with multiple angles, while here you are dealing with two different, angle variables themselves. Right? So instead of it condensing to some kind of a beautiful expression like 4x or 2x or something like that, we're going to be left with some janky thing like x minus y. But it's the same, the same old story. So again, taking L because the right hand side is very simple. L is going to be equal to sin x minus sin y divided by cos x plus cos y, right? This is formula. Sin A minus sin B is going to be 2. This is 2 cos of x plus y by 2, right? It's 2 cos A plus B by 2 into sine of x minus y by 2. Whole divided by, this is cos x plus cos y. Remember the formula again, it is going to be 2 cos of x plus y divided by 2 into cos of x minus y divided by 2. 2 cos x plus y by 2 is cancelled out. And you are basically left with sine of x minus y divided by 2 divided by cos of x minus y divided by 2, which is equal to tan of x minus y divided by 2, which is basically equal to the right hand side. Therefore, you have to the expression, right? Since LHS is equal to the RHS. Right. Question number 8. Question number 19. Back to multiple answers, right? So again, I leave the left hand side only. Right? Sin x plus sin 3x by cos x plus cos 3x is tan 2x. Fairly simple, right? So the left hand side is going to be sin x plus sin of 3x. At this point, I'm just going through the motions because these questions, this question and this question are very, very, very similar. The only place where it's different is this part, right? These are 5x, that's on the NX. But you notice the difference, right? Get this exercise. Since you have seen that sin x plus sin 3x by cos x plus cos 3x is also tan 2x, try finding out what sin 5x plus sin x divided by cos 5x plus cos x is, right? Or maybe something like instead of this being plus x, try finding out what sin 5x plus sin of minus x divided by cos 5x plus cos of minus x. Right. Here we have decreased 4 over here. Try decreasing 4 over here and see what the answer is. That's what I'm trying to say. This is the left hand side expression. Remember the sine and the cos formula. Sin x plus sin 3x is going to be 2 sine of 4x by 2. That is going to be 2x into cos of this is what 3x minus x by 2, that is going to be x divided by this is going to be 2 cos of x plus 3x by 2, that is going to be 2x into cos of x minus 3x by 2, that is going to be x. So cos x and cos x cancelled out, 2 and 2 get cancelled out. You are left with sine 2x, sine of 2x divided by cos of 2x, which is equal to tan of 2x, which is equal to the right hand side. Therefore, LHS is equal to RHS. Therefore, all right, that's 19 done. Question number 20. Sin x minus sin 3x by sin square x minus cos square x is 2 sides. Right? Again, right hand side is a fairly simple expression. I only deal with left. L is equal to sin x minus sin 3x divided by sin square x minus cos square x. Remember that cos square x minus sin square x is the formula for cos 2x, right? So this is basically minus cos 2x. Remember that. All right. I mean, I'll make the substitution, but remember this for future, right? So the numerator is going to be your normal sin x minus sin x, right? Is going to be 2 cos of x plus 3x by 2, that is going to be 2x, into sine of x minus 3x by 2, that is going to be minus x, whole divided by minus cos of 2x. Cos 2x and cos 2x is cancelled out. You are left with minus 2 times minus sin x, right? Minus and minus cancel out. This becomes 2 sin x, which is equal to the right hand side. Therefore, LHS is equal to the RHS. Therefore, I have to the expression. Question number 21. Cos 4 plus cos 3 plus cos 2 divided by sin 4 plus sin 3 plus sin 2 is going to be equal to cot 3x. Right? Notice that this angle is the arithmetic mean of this angle and this angle. So the first thing you have to think of doing is condense this, right? Condense this along with this, right? Why is everything getting selected? What the hell is this? So you do you deal with this cos and this cos, this sine and this sine, instead of dealing with the middle. Because if you're going to do this, then you will anyway get a 3x term with which you can take common and simplify out. Right? So question number 21. I'll again deal with the left hand side because the right hand side is simple. I can't simplify it further or I can't apply anything on it. All right. So L is equal to, this is cos 4x plus cos of 3x plus cos of 2x whole divided by sine of 4x plus sine of 3x plus sine of 2x. As I told you earlier, deal with this and this, this and this, right? So this is equal to cos 3x divided by, this is sine 3x, this plus cos 4 plus cos 2 is going to be 2 cos of 4x plus 2x divided by 2, that is going to be 3x, into cos of 4x minus 2x divided by 2, that is going to be x. Right? And this is going to be sine 3x plus, since this is sine plus sine, you are going to have 2 sine of 3x. And this is going to be cos x. Right. So I'll take cos 3x common over here. This is going to be cos 3x times 1 plus 2 cos x divided by, this is going to be, I'll take sin 3x common in the denominator. This is going to be sin 3x times 1 plus 2 cos x. Notice that this and this are the same. You can cancel it out, right? Provided that cos x is not equal to this is what is not equal to minus half, right? You can only cancel it out if the denominator is not 0. Remember that, right? So cos x should not be equal to minus half. If cos x is minus half, then you can't cancel it out. You get a 0 by 0 form, which is basically tending to infinity, which is not real, right? And anyway, you have to make sure in every case that the denominator is non-zero. But that's a different matter altogether. Yeah, so whatever. Right. So you are going to be left with cos of 3x divided by sine of x, right? Which is equal to cot of 3x, which is the right hand side. Therefore, you have shown that the LHS is equal to the RHS. Therefore, you have to state. Question number 22. Right? This is cot x, cot 2x, minus cot 2x, cot 3x, minus cot 3x, cot x is equal to 1. So, over here, what you can do is, take something common out, right? Since the right hand side is basically one number, that is 1. I take the left hand side, that is what I can simplify. So I'll write the left hand side out first. Cot x, cot of 2x, minus cot 2x, cot 3x, minus cot x, cot 3x. Right? In this, I can first take cot 2x common out into cot x minus cot 3x minus, this is going to be cot x cot 3x, right? Instead of this, what I'll do is, instead of 2x, I'll take 3x common. Right? Because if I take 3x common, then I can split this as 2x plus x, and I can, hopefully cancel out the numerator and denominator. Yeah. So if I take cot 3x common, then what I'm going to have is, this is going to be minus cot 3x. This is minus cot 3x into this is cot x plus cot of 2x. It's going to be 2x. Right? And this is going to be a plus. This is going to be cot x. This is going to be cot 2x. So I'll split this as minus cot of x plus 2x plus cot x cot 2x. Right? Since we know the formula for tan of x plus y, we know the formula for cot of x plus y, right? Cot of x plus 2x is going to be equal to, this is what, cot x into cot of 2x minus 1 divided by, this is cot x plus this is cot of 2x, right? Into, this is cot x plus cot 2x. So the denominator and the numerator term gets cancelled out, and you are left with another cot x cot 2x term. Right? This is cot of 2x. Correct. So this is basically 1 minus cot x cot 2x plus cot x cot 2x. Cot x into cot of 2x. So this and this cancel out. We are finally left with 1, which is equal to the RHS. Therefore, I can say that LHS is equal to RHS. Therefore, I have to say. Now going to question number 20. Twenty-three says that tan 4x is equal to 4 tan x into 1 minus tan square x divided by 1 minus 6 tan square x plus tan power 4x. Over here again, I'll deal with LHS. because the RHS is going to be very time consuming to actually condense down because you're dealing with powers of tan and not multiples of x. All right. So L is equal to tan for x. I hope you all know the formula tan of 2x. I think it's given us the rule also. But anyway, I'll restate it over here. Right? Tan 2x is basically 2 tan x divided by 1 minus tan squared x. Right? So tan of 4x can be written as tan of 2 into 2x, right? Which is basically 2 tan of 2x divided by 1 minus tan squared 2x, which can further be written as 4 tan x by 1 minus tan square x divided by 1 minus 2 tan x by 1 minus tan square x the whole square. Right? So, what I'll do is I'll multiply numerator and denominator by 1 minus tan square x. Right? This will go, and I include a root over here to show that I just have one more, 1 minus tan square x in the denominator after this one that is squared out. All right. If I have to remove this also, then I'll have to multiply again by 1 minus tan square x. Right? So I'll be left with 4 tan x into 1 minus tan square x right? This will be instead of making a rule over here, I'll just multiply this by 1 minus tan square x the whole square, right? And over here, multiply this by 1 minus tan square x the whole square, and 1 square gets cut off with this, right? So you have 4 tan x into 1 minus tan square x on the numerator, while in the denominator, you basically have 1 minus tan square x the whole square minus this is 4 tan square x. Right. So you basically have this to be 4 tan x into 1 minus tan square x divided by this is going to be 1. There is going to be minus 2 tan square x over here, which along with minus 4 tan square x, I'll basically write it as minus 6 tan square x plus there is going to be 1 tan power 4x. Right? Which is basically what's given on the right hand side in the equation. Therefore, I can say that LHS is going to be equal to RHS. Therefore, I have to be safe. Right? Question 24 and 25 are in the same way. Right? You have to prove a multiple angle formula of a higher multiple than 2 and 3. Right? Which is basically, not that difficult. It's just long. And, you have a lot of places where you can make a mistake when it becomes very long. Right? Similarly, for question number 24, you are going to deal with cos of 4x, right? Cos of 4x is going to be equal to my left hand side equation, right? Remember that cos of 2x is basically 2 cos squared x minus 1, right? Which is also equal to 1 minus 2 sine square x. Why I have written both these forms is because you have a sine square x, you have a cos square x over here. That is why you have to be careful in, writing down cos 4x. Now, I can write down cos of 4x as cos of 2 into 2x. That is going to be 1 minus 2 into, this is sine squared of 2x, right? Using this formula. Remember that sine 2x is equal to 2 sin x cos x, right? By far the easiest formula to remember this. The second easiest is cos x, which is basically cos square minus sine square. Right? And the different forms you can just basically get it from the identity that cos square plus sine square is 1. So not a big deal. Right. So cos 4x is 1 minus 2 sine square 2x, which on applying this identity reduces down to 1 minus 2 into 2 sine x cos x the whole square, which is basically 1 minus 2 into 2 squared sine squared x cos squared x, which is basically 1 minus 8 sine square x cos square x. All right, which is basically the right answer equation. Therefore, LHS, this is LHS is equal to RHS. Therefore, I have this statement. And finally, the last question of exercise, question number 25. Right? Cos 6x is equal to 32 cos par 6x minus 48 cos par 4x plus 18 cos square minus 1. Again, let me deal with the LHS. This is cos of 6x. Again, is the same old vein as 23 and 24. We are going to do the same thing, right? But instead of this being 2 into 2x, I'll basically be dealing with this is equal to, since I have to represent this purely in cos, right? I'll represent cos of 6x as cos of 3 into 2x, right? Remember the formulas. Cos 3x is going to be equal to 4 cos cube x minus 3 cos x, and cos of 2x is going to be equal to, the formula I'll be using in this sum is going to be 2 cos squared of x minus 1. Right? Because as you can see, there is no sine square x in the right hand side of this equation. So I should not use any expansion where there is a sine term. All right. So since I'll write cos 6x as cos of 3 into 2x, I can expand L to be this to be using cos 3x formula. I can write this as 4 cos cubed of 2x minus 3 cos of 2x, right? Which is basically equal to 4 times substituting cos 2x over here. This is going to be cos squared x minus 1, wait, 2 cos squared x minus 1, right? The whole cube minus 3 cos x. Right, you can't simplify cos x further. This is, I'm sorry. This is 3 cos 2x, right? So this will be 3 into 2 cos squared x minus 1. So over here, you're going to deal with 4 times. The Q of this equation is going to be this basically A minus B the whole cube. That is going to be A cube, that is 8 cos power 6x minus 3a squared b. That is going to be 3 into 4, that is going to be 12 cos power 4x plus 3ab squared, that is going to be 6 cos squared x minus b cube. Right? This is going to be in conjunction with minus, this is 6 cos squared x plus 3. Right? Removing the, the pre-multiplied 4, right? I'll basically write this as 4 is a 32 cos power 8, cos power 6x, cos, I'll get this properly. 32 cos power 6x minus, this is going to be 48 cos power 4x plus, this is 4 into 6, that's 24. 24 minus 6 is going to be 18 cos squared x. And this is going to be minus 4 plus 3, that is going to be minus 1. Right. This is LHS, which is equal to the RHS. Therefore, I can state that LHS is equal to RHS. Therefore, I have two statements. And with this, we complete exercise 3.3. The only thing left is miscellaneous exercises, right? And again, as I told you earlier, look at these miscellaneous examples because there are a lot of questions which make you think differently, which make you realize that these kinds of questions can also be asked. All right. Yeah. Look at this. I told you, right? I asked you before about, I told you before about pi by 8, that is 22.5 degrees. And what I've done is taking x to be pi by 8, then 2x is going to be pi by 4. So they have applied the tan 2x formula from which they have gotten this tan of pi by 8 out, right? This basic substitution of variable, and then they have, substituted the value for tan pi by 4. They have used y over here. Convert this to a quadratic expression. And then you solve the quadratic, you get this formula. That's -1 plus -2. Right? And since x is pi by 8, that means that tan pi by 8 has to be positive. Right? And so root 2 minus 1 is going to be the value of tan pi by 8. That's how they are given the answer. Right? Or you can use the half angle formula, which is not given in the textbook sadly. But if you want to reconstruct the net, you can get to know the half angle formula also. They're not that important. Cool. So starting this miscellaneous exercises. Right? Question number 1. Prove that 2 cos 5 by 13 cos 9 pi by 13 plus cos 3 pi by 13 plus cos 5 pi by 13 is going to be equal to 0. All right. So, just a sec. Right. Remember the formula for 2 cos A cos B. Right? Let me write this out. The left hand side, since the right hand side is 0, I'm just directly going to the left hand side. Left hand side states that 2 cos of 5 by 13 into cos of 9 pi by 13 plus cos of 3 pi by 13 plus cos of 5 pi by 13. All right. So you will basically, what you can do is either condense this to form some kind of a plus expression, right? Or what you can do is you can add these two to form this kind of a multiplied expression. Right? Both ways, or you can get the answer. Right? Easier way is to add these two. Right? And then the reason why I told you to remember the formula for 2 cos A cos B is because that may also be tested, and sometimes you'll find that you cannot avoid using that formula also. Very digress. Right, so I'll basically keep this as such. This is going to be 2 cos pi by 13 into cos of 9 pi by 13 plus, since I'm going to add these two, I'm basically going to get 2 cos of 3 plus 5, 8 pi by 13 divided by 2. That is going to be 2 cos 4 pi by 13 into cos of 5 minus 3 is 2 and 2 by 2 is 1. So I'll again get a cos pi by 13. Notice that 2 cos pi by 13, 2 cos pi by 13 is there in both expressions. So I can basically take that common out, right? So this is going to be 2 cos pi by 13 L, right, into cos of 4 pi by 13 plus cos of 4, and this is going to be 9 pi by 13. Right? Notice that one is basically pi minus the other. So basically, this is equal to 2 cos of pi by 13 into, this is cos of 4 pi by 13 plus, this is cos of pi minus 4 pi by 13. Right? This is basically minus cos 4 pi by 13. If you remember, cos of pi minus theta is minus cos theta, right? And so cos 4 pi by 13 plus this is going to be equal to 0. Therefore, you are basically having something multiplied by 0. Right? And that something is going to be 2 cos of pi by 13, which is equal to a big fat 0, which is the right hand side. Therefore, LHS is going to be equal to RHS. Therefore, I have to be straight. Very simple. Sin 3x plus sin x and sin x plus cos 3x minus cos x and a cos x is again going to be 0. Correct. There are two ways to do this question, right? The long way is to, not think on it by any chance, right? And directly add sin x and sin 3x, subtract cos 3x from cos 3x and cos x, and then multiply it by sin x, multiply this by cos x, add them both, you'll get a 0. You'll 100% be guaranteed to get a 0, but this is going to be the long way. The shorter way is to use a little bit of your brains, right? And multiply this, remove the brackets. So you will, what you'll get is, right, let me write the question. Left hand side is going to be, this is sine of 3x plus this is sin x times sin x plus this is cos of 3x minus cos x whole into cos x, right? This is going to be the left hand side. What I'll do is, I'll separate, remove the brackets. So I'll be having, this is sine 3x times sin x, right? And over here, I'll have a cos x into cos x. So I'll write this over here. This is plus cos 3x into cos x, right? Plus, this is going to be sine squared x. This is going to be sine squared x. This is going to be minus cos squared x, right? Remember that I've told you already what this is. This is basically minus of cos of 2x, right? So this is equal to this whole expression, that is sin 3x sin x plus cos 3x cos x is really reminiscent of cos of 3x minus x, right? Because cos a minus b is going to be cos a cos b plus sin a sin b, right? So I can basically combine this whole thing to form cos of 3x minus x or x minus 3x, whatever. Does not make a difference, right? This minus cos 2x, right? Because this whole thing is minus cos 2x. And there's a plus over here, plus and minus is minus, right? L is equal to this. So this means that L is basically equal to cos of 2x minus cos 2x, which is equal to 0, which is equal to the right hand side. Therefore, I can state that LHS is equal to the RHS. Therefore, therefore, I have to be stated, right? Question number 3. Cos x plus cos y the whole square plus sin x minus sin y the whole square is 4 cos squared of x plus y by 2. Right. Again, instead of directly directly adding over here and then squaring and adding, right? You can do that. That is also fairly simple. I mean, there's not really a big difference, to be fair, right? So I'll do that method, right? Because that is really very easy and not much good. So L is equal to this is cos x plus cos y the whole square plus sine of x plus sine of y the whole square. In case anyone is wondering why you can't directly say that this plus this is 1, is because cos x plus cos y is not, does not correspond to any value of cos or sine, for which the other complement value is going to be sin x plus sin y, right? So you can't directly state that this plus this is always equal to 1. The only time when the both of the the sums are going to be equal to 1 is then you will never get this to be 1. Prefer, because if you expand it out, you will get a plus 2 cos x cos y and a plus 2 sin x sin y terms. That'll actually throw you off. Yeah, only when one is 90 and the other is, yeah. I mean, even then, whatever. So, yeah. My ramblings aside, I'll add cos x and cos y over here. I'll add sin x and sin y over here. So, inside, I'll basically get 2 cos of x plus y by 2 cos of x minus y by 2 the whole square, plus this is going to be 2 sine of x plus y by 2 into cos of x minus y by 2. Right? So I'll basically take 2 cos x minus y by 2 the whole square out common from both. Right? So I'll basically have 4 cos square of x minus y by 2 whole into, this is going to be cos squared x plus y by 2 plus sin square x plus y by 2. So this is going to be cos square of x plus y by 2 plus, this is going to be sin square of x plus y by 2. Right? This is basically 1. This is basically 1. Right? And anything into 1 is this anything. Therefore, I just directly skip a step and write that this is equal to 4 cos square of x minus y by 2. And this is the left hand side. This is equal to the right hand side. Wait a minute. Okay, I made a mistake. I made a mistake. Sorry. So here is a minus. So over here, I'll get that this has to be a minus and this has to be a plus. So over here, there will be a plus. Over here, both these cases, there will be a minus. And so you'll be left with a plus over here. Right. Sin x minus y by is 2 sin of x minus y by 2 cos of x minus y by 2. Using that, I'll take 2 cos x plus y by 2 as common out. And that is going to be your final answer because the rest of the term is going to be cos squared x minus y by 2 sin squared x minus y by 2. And since it's addition, it's going to be equal to 1. And whatever into 1 is the problem. Yeah. Therefore, you have stated that LHS is equal to RHS. Therefore, you have proved that's number 4. Cos x minus cos by the whole square plus sin x minus sin by the whole square is 4 sin square x minus y. Same as this. The only place where you're going to change is this plus. Right? So again, same old. I'm going to do this with minimal explanation because I've already done a very, very similar sum earlier. So this is going to be the whole square. Plus this is going to be sin x minus sin y the whole square. Right? Which is going to be 2 sin of y minus x by 2 sin of x plus y by 2 the whole square. Plus this is going to be 2 cos x plus y by 2 sin of x minus y by 2 the whole square. Right? So I can basically state 4 sin squared of x minus y by 2 to be common out. Right? Because if I square sin of y minus x by 2, taking a negative outside is not going to make any difference because minus 1 the whole square is again plus 1. Yeah. So I can basically take this common out. I'll be left with sin squared of x plus y by 2 plus cos squared of x plus y by 2, which basically make 1. And so I can state that the LHS is going to be equal to 4 sin squared of x minus y by 2, which is basically the RHS. Therefore, right? That's question number 4 then. Question number 5. Sin x plus sin 3x plus sin 5x plus sin 7x is 4 cos x cos 2x sin 4x. Right? Notice that the sum of this and this is going to be equal to the sum of this and this. That's a clue. Right? And over here you have sin 4x. That's the other clue. So basically, what we're going to do is LHS is going to be equal to sin x plus this is sin 3x plus this is sin of 5x plus this is sin of 7x. Right? I'll rearrange this as sin x plus sin of 7x plus I'll rearrange this as sin 3x plus sin 5x. Alright. So what I do is add these both, right? You know the formula, it is going to give you 2 sin of 4x into sin of 3x. Plus add this, you know the formula again, it is going to give you 2 sin 4x into cos of, this is going to be what 5 minus 3 is 2, so this is going to be cos x. Okay, there is sign here as well. Cos. Sorry for that. Yes, 2 sine of a plus b by 2 cos of a minus b by 2. So I'll take 2 sine 4x common out. You are going to be left with cos of 3x plus cos of x, right? And this again, you're going to use the formula. Right? This is 2 sine 4x times this is cos 3x plus cos x. That is going to be what? 2 times cos of a plus b by 2. That's going to be cos 2x, and a minus b by 2. That's cos x. Right? Therefore, L is going to be equal to 2 into 4 the cos x, the cos of 2x into sine of 4x, which is equal to the right answer. Therefore, you can state that LHS is equal to RHS. Therefore, you have proved the expression. H. That's question number 5. Question number 6. Right? Sine 7 plus sine 5 plus sine 9 plus sine 3 divided by cos 7 plus cos 5 plus cos 9 plus cos 3 is tan 6. Right? Very simple. It's almost same as question number 5. Right? But the only problem is you have a numerator and denominator. Yeah. Doesn't make a difference, to be fair. Yeah. So take the LHS again. Right? You have this to be sine of 7x plus sine of 5x plus this is sine of 9x plus sine of 3x whole divided by cos of 7x plus cos of 5x plus this to be cos of 9x plus cos of 3x. Right? Apply the sine A plus sine B cos A plus cos B formula of twice, right? Each twice. So what you get is over here you'll get 2 sine of 6x and sine of 7 minus 5 is 2, so you get sine x over here. Right? You get cos x over here. Cos x over here. Plus here it's 9x plus 3x, so you'll get 2 sine of 6x again, but you'll have cos of 9 minus 3 is 6, so you'll have cos of 3x. All divided by this is cos A plus cos B, so you'll be left with 2 cos of 6x into cos of A minus B, that is A minus B by 2, that is 2x. So you'll have a cos x term over here. Plus this is again 9x plus 3x, so you'll have 2 cos of 6x because 9 plus 3 is 12, 5 plus 7 is 12, and 12 by 2 is 6. Right? Into cos of this is 9 minus 3, so that's 6, 6 by 2 is 3x. Taking all the common terms out, you basically have 2 sine of 6x divided by 2 cos of 6x into this is basically cos x plus cos 3x divided by again it's cos x plus cos of 3x, right? Both get cancelled out. The 2's get cancelled out, And you are basically left with L is equal to sine of 6x by cos of 6x, which is equal to tan x, tan of 6x, right? Which is equal to the RHS. Therefore, you can say that LHS is equal to RHS. Therefore, right? The last proving question. Sin 3x plus sin 2x minus sin x is 4 sin x cos x by 2 plus 3x by 2. So the right hand side, I can't really simplify, right? If I have to do that, I have to take 2 cos x by 2 plus 3x by 2 and then go ahead and separate things out. But yeah, I'm not willing to do that. So I'll go from the left hand side itself. So L is equal to sine of 3x plus sine of 2x minus sine x. Right? Notice that this and this, the arithmetic mean is going to be this. So I'll subtract this from this. Right? This is equal to sine of 2x. No, wait. I should not do that. Because if I subtract this from this, I'll be left with a cos 2x expression instead of a sin 2x expression, and I can't really do anything with that. Right? So what I'll do is I'll add this and this. Right? And then wait, then I'll be left with sine half sine x by 2. Right? That's worse. Okay, wait. I'll go with this. See where it end up. Right? This is sine 2x plus 2 times, since this is sine a minus sine b, you will get cos of a plus b by 2, that is going to be cos 2x into sine of a minus b by 2, that is going to be sine x. Right? Because 3x minus x is 2x and 2x by 2 is x. 3x plus x is 4x, 4x by 2 is 4x. Right? And now I'll separate sine 2x out into 2 sin x cos x. And this I'll retain as 2 sin x into cos 2x. Right? So I'll take 2 sin x common out. I'll have this to be cos x plus cos of 2x, which is basically 2 sin x into 2 cos of x plus 2x is 3x by 2 into cos of x minus 2x is minus x by 2. Since it's cos, it's even. Cos of minus x by 2 is the same as cos of x by 2. So I'm not bothering with the minus. Right? Therefore, I can write L is equal to 4 into cos x by 2 into sin x into cos of 3x by 2. Which is equal to R. Right? In increasing order of the the parameters, x by 2, x and 3x. That's what I've written it. If you want to write it as sin x cos x by 2 cos x by 2, go ahead. If you want to write it as cos x by 2 sin x and cos x by 2, go ahead. There's not really a big difference. It's just make it first time. Cool. So you can state that LHS is equal to the RHS. Don't have final time I state that, sadly. Therefore, I have to state. With that, we finish all the proving type questions. And we are left with the 3 different half angle. Right? Find sin x by 2, cos x by 2, and tan x by 2 in each of the following. When question number 8. Right? We are given that tan x is minus 4 by 3 and sin x is positive. Right? Or wait, instead of sin x being positive, I should write this as x belongs to quadrant. Right? Why I shouldn't write sin x is positive is because if sin x is positive, that means that x can be in either quadrant 1 or quadrant. When taken along with tan x is minus 4 by 3, it means that it's in quadrant 2. But that's generally not the way to do it, because that's very, very implicit. And you do not want any ambiguities to be there when you are dealing with the business. So I write that x is in quadrant 2. If x is in quadrant 2, right, that means that pi by 2 is less than x is less than pi. Remember this, right? Because when you're dealing with half angles, what happens is you have to see where x by 2 lies and not x. So since x by 2 lies between pi by 2 and pi, your x by 2 is going to lie between pi by 4 and pi by 2. Or this is going to lie in quadrant 1. All right. Having this in mind, having this in mind, we know that tan x is minus 4 by 3. Right. And you know that your tan of x by 2, right? No. Since you are not given the half angle formulas, you'll have to do it with tan of 2x and etc. Right. So tan of 2x by 2 is going to be equal to 2 tan x by 2 divided by 1 minus tan square x by 2. Right? Let this whole thing, this tan of x by 2, let this be y. All right. So tan x, which is minus 4 by 3, is going to be equal to 2y squared divided by 2y by 1 minus y squared. Right? So taking this to the other side, taking just keeping nothing in the denominator, taking this here, taking this, I just cross multiply. Right? This equivalent. This means that minus 4 plus 4y squared is equal to 6y, or 4y squared minus 6y minus 4 is going to be equal to 0. Right? That means y is equal to minus b plus minus root of b square minus 4ac, that's 4, that's 6, right? Divided by 2a. This is basically 100. So root of 100 is 10, right? So y is equal to 6 plus minus 10 divided by 8. Since you know that y is greater than 0, right? Because y is tan half, tan x by 2, and x by 2 lies in the first quadrant, so tan x by 2 is positive. Right? So y is positive. Since y is greater than 0, this means that y is equal to, from this you can get that y is equal to 6 plus 10, 16 by 8, that is 2. Or it can be 6 minus 10 by 8, that is minus half. Right? Since y is greater than 0, this means that y is equal to 2. Or you can say that tan of x by 2 is equal to 2 by 1. Right? Or is equal to 2, whatever. From tan x by 2, what you can get is secant squared x by 2 is going to be equal to tan square plus 1 is secant square, right? So this is basically 1 plus tan square of x by 2, that is going to be 4, or this is going to be 5. Therefore, cos squared x by 2 is going to be equal to 1 by 5, which means that cos of x by 2 is going to be equal to 1 by root 5. Right? Since x by 2 is in the first quadrant, cos of x by 2 is positive, cos x by 2 is 1 by root 5. And finally, since cos x by 2 is 1 by root 5, I can get the value of sine of x by 2, right? Which is basically tan x by 2 into cos x by 2, which is 2 into 1 by root 5. 2 into 1 by root 5. This equals 2 by root 5. Right? So you have the three values, that is sin x by 2, tan x by 2, and cos x by 2 for x being equal, or tan x being equal to minus 4 by 3 in the second quadrant. Cool. Just a moment, my mouse is stopped working. Right. Therefore, for this question, I just write this set of values over here. Sine of x by 2 is equal to 2 by root 5. Cos of x by 2 is equal to 1 by root 5. Right? And tan of x by 2 thus is equal to 2. These are the three values you're dealing. All right. The second last question, number 9. Cos x is minus 1 by 3 and x belongs to the third quadrant. If this is the case, then remember that pi is less than x is less than 3 pi by 2. Right? Which means that since you're dealing with half angles, x by 2 is going to be less than 3 pi by 4 and it is going to be greater than pi by 2. Which means that x by 2 lies smack in the middle of the second quadrant. Right? Second quadrant means that sine is positive, cos is not, tan is not. Having cleared that up, since cos x is minus 1 by 3, right? You can get the value of tan x, from which it's going to be easy to figure out the rest, right? So since cos x is minus 1 by 3, your tan x is going to be equal to square root of 1 minus cos square x divided by cos x, right? And a minus over here. This is a minus, right? Because sin x is going to be negative, but a root of anything is going to be positive. So I have to add a minus over here. This is going to be minus square root, or instead of minus, I just say square root of 1 minus, this is going to be 1 by 9, right? It's going to be 1 by 9 divided by 1 by 3. This minus and the minus of this minus 1 by 3 gets cancelled out. Right? So this is going to be equal to 3 root of 8 by 9. This 9 and this 3 get cancelled out. So I'm left with 2 as tan x. Right? So I'll write the equation as 2 root 2 is equal to 1 minus y. Wait a minute. This is going to be 2y divided by 1 minus y square, where y is equal to tan of x by 2. Right? And y is less than 0. Remember that. So this 2 and this 2 get cancelled out. I am left with a root 2 minus root 2 y squared is going to be equal to y. Or root 2 y square plus y minus root 2 is going to be equal to 0. Thus, y is equal to minus b plus minus square root of b square minus 4 into a into c. ac is going to be 2 plus, so this is going to be 1 plus 8 divided by 2 root 2. Since this is 1 plus 8, this is 9, root 9 is 3. This is going to be minus 1 plus minus 3 divided by 2, right? Which is going to be either this is 1 by root 2 or it is going to be minus 2, right? Since y is less than 0, means that y is equal to minus 2. So you have the fact that tan of x by 2 is going to be Right, which means that secant squared x by 2 is going to be 1 plus tan square, that is 3. Right? So cos of x by 2 is minus, right? So cos of x by 2 is going to be, since x by 2 lies in the second quadrant, this is negative, right? Cos of x by 2 is going to be minus 1 by root of secant square x by 2. That is going to be minus 1 by square root. Right? Therefore, sine of x by 2 is going to be tan x by 2 into cos x by 2. That is going to be square root 2 by square root 3. Right? Therefore, I'll write the three expressions here. Sine of x by 2 is equal to square root of 2 by 3. Cos of x by 2 is equal to minus 1 by square root 3. And tan of x by 2 is equal to minus square root of expressions. Right. Thus, you finish question number 9. Finally, go to question number 10. Right. Sin x is equal to 1 by 4, but x belongs to the second quadrant. This means that x by 2 belongs to the first quadrant. Right? Because that's what happened in question number 8, and that's what we found in question number 8. Right. Since sin x is 1 by 4, this means that tan x is going to be 1 by 4 divided by minus root of 1 minus 1 by 60. Right? It's sin x divided by root of 1 minus sin square x. Since cos x is going to be negative in the second quadrant and tan x is going to be negative, I will introduce a minus sign over here because roots are always positive. Right? So this is basically minus 1 divided by, since I have a 4 over here, this is root of 16 minus 1, or tan x is basically minus 1 by root of 3. Right? From this, I can figure out tan of x by 2. Right? I'll basically write that minus 1 by root 15 is equal to 2y divided by 1 minus y squared, where y is equal to tan of x by 2 and y is greater than 0 because x by 2 lies in the first quadrant. Right. So with this in mind, I'll basically, cross multiply and state that y square minus 1 is equal to 2 root 15 into y, or y square minus 2 root 15y minus 1 is equal to 0. Thus, y is equal to minus b plus or minus square root of b square is 16 plus 4ac, or minus 4ac is plus 4 into 1 into minus 1, whole divided by 2, which is equal to 2 root 15 plus or minus 8 divided by 2, because 16 plus 4 is 64, root 64 is 8. Right? And you can basically cut this off. This is root 15 plus 4 or root 15 minus 4. Notice that root 15 is less than root 16, that is 4. Since square root is monotonically increased, that means that root 16 is greater than root 15. Therefore, this is a negative number. Right? Since y is positive, this cannot be the value of y. Therefore, y is equal to root 15 plus 4. Alright. This is because y is greater than 0. So you have the value of tan x by 2, right? From this, you can basically state that secant square x by 2 is going to be 1 plus this whole square, right? And this whole square is going to be 16 plus 15 plus 8 root 15, right? So that is 31 plus 8 root 15. Secant square x by 2 is going to be 1 plus what? I'll just write this down because I don't want to make a mistake over here. Right, so this is going to be 1 plus 16 plus 15 plus 2 into 4 into root 15, that is 8 per root 15. That is going to be 16, 15 is 31 plus 1 is 32 plus 8. Right. With this, I get a secant square. So cos of x by 2. Since x lies in the first quadrant, this is going to be positive. So I'll be taking plus 1 by square root of secant square x. That is going to be 1 by root of 32 plus 8 root 7. Right. Which is basically 1 divided by, if I take 4 outside, this is going to be 4 into, this is 8 plus 2 root 50. Right, so I'll just make this as 2 root of 8 plus 2 root 50. Wait a minute. Yeah. So cos of x by 2 is going to be 1 by 2 root of 8 plus 2 root 50, right? Which if you want to rationalize, because not many people like to leave a root in the remainder or in the denominator. Sorry. If you want to rationalize this, what will happen is you will multiply this by square root of 8 minus 2. Yeah. So this will be square root of 8 minus 2 15 divided by 2 into square root of, this is 64 minus 60, that is going to be 4. So you will basically be left with square root of 8 minus 2 root 15. 8 minus 2 root 15 divided by 4. Right? That is going to be the value of cos of x by 2. Therefore, sine of x by 2 is going to be equal to this whole thing into tan x by 2, right? So this is going to be 4 plus root 15 divided by, this is 2 root of 8 plus 2 root 15, right? So if I have to, cut this off, I'll just multiply this by 2 and this by 2. So I basically get 8 plus 2 root 15 divided by 4 root of 8 plus 2 root 15, right? Which I can further write a square root of 8 plus 2 root 15 divided by 4. Right. And that concludes the short time. Instead of doing all this, the easiest, simplest and easiest way to go about this, right? Let me just write the values over here because I forgot to do that. So sine of x by 2 we have found to be square root of 8 plus 2 root 15 divided by 4. Cos of x by 2 we have found to be square root of 8 minus 2 root 15 divided by 4. And tan of x by 2 we have found to be 4 plus root 15. Right. Instead of doing all this, there are actually very way easier formulae, right? For half angles, you usually say that sine of x by 2 is equal to 1 minus cos x by 2 whole under root. You say that cos of x by 2, right? Cos x by 2 is going to be equal to square root of, wait, cos x by 2 is going to be square root of 1 plus cos x divided by 2. And tan x by 2 is going to be equal to, this is sin x by cos x, right? So if I, rationalize this, I'll basically get this to be 1 minus cos x divided by sin x. Right. These are the three half angle formulae, which, you can convert to sin or tan or whatever. Right. But the cos form is way, way, way easier. And how you get this is from the cos 2x formula. Right? That is the easiest method. Right? Cos 2x is equal to 2 cos squared x minus 1. Right? So from this, 1 plus cos 2x by 2 is going to be cos square x, or 1 plus cos 2x by 2 whole under root is going to be cos x. Right? Substitute x for x by 2, then you get this. Right? And if you use the 1 minus 2 sine squared x formula, you get this, right? And this by this is going to give you this. These are the half angle formulae, right? You may use them, you may not use them. It does not matter, right? Finally, just show your working, show your steps. That should be enough. You'll get full marks. Yeah, with that, we end with this chapter, right? Look at the summary because, again, saying all the formula are given here in a concise way, and you can just, refer to it like a formula sheet or whatever. Right? Do not just stamp paper it and go and copy in your exam because that's not help at all. Right. With that, we finish this chapter. Thank you all for listening. Hope you have a nice day.